So hello everyone, in the last session we are seeing about the different types of method to calculate equivalent resistance, and we have also covered about the horizontal plane symmetry and the vertical plane symmetry. In today's class we are going to first cover about the infinite ladder case, and then we will see about the how to calculate R equivalent for the different combinations of a cube in cube combination basically. So let us start. The first thing we are going to see, erase it, okay. So first thing we are going to see is about infinite ladder case. Okay, what is infinite ladder case? Let us there are a lot of misconceptions are there. We will remove it. Okay, infinite ladder case. If we see, there are the two types of cases are there, but for you generally one type of case is very important. Okay, we will see that case, and if it is required we will go for the another case also. Okay, that is generally for the basically for the Olympiad and that, but we can see that case, we will see it in the end of the chapter. Okay, so let us take a one example, because we have to understand this with example. Suppose there is a point A is there, and suppose this resistance is R, there is another resistance R is there. Okay, suppose this point is B, this point is A, another we have a resistance R, this is R. Okay, 1 minute, yeah, this thing, suppose this resistance is again R, this is R, and suppose this whole thing is happening up to infinity times, means this circuit is repeating up to infinity. Okay, this thing is going to be repeated up to infinity. So my question is that what is RAB, means what is R equivalent across AB? How to find this? See, what is a basic approach? See, at infinity this circuit will be there, so these two will be in series, correct, R and R, that they will be parallel with this, and as soon as this is going to be repeated, correct. But if you try to understand what is the approach, there is a method. Okay, you can't say that why this is we are doing, because this is a proper method, you have to follow that method. Okay, if you want to solve, if you don't want to solve, then do it normal way which you know. Okay, in that way you won't get the answer. What is the method is basically, if first try to see which part is going to be repeated every time, just try to identify the repeating part. The repeating part is what? If you see, this part is going to be repeated everywhere, correct. So what you have to do, you have to, if you see the R equivalent from here also, what I'm trying to say, if you see the R equivalent from here, okay, in spite of seeing from here, you just see the R equivalent from here, RAB. Suppose let RAB is X. So if you see from here also, if you see from here also, RAB, or you can say not RAB exactly, or you can say R net. Here from here also, what you will get from here? If you will see the R net, you will get X, correct. R net, what you will get? You will get X, correct. Is there is any doubt till here? No. So we can replace this circuit, replace it by this circuit. This is R is given, this is R also given, this is R also given, and at this point we have X, correct. This point is A, this point is B, so these two will become, so XR upon X plus R, and this is parallel with 2R, that is equal to X. Because this R equivalent, here also you will get the same RAB. If you see the RAB, again you will get X only, correct. So that is whole R net is equal to X. Now you calculate this. This is XR, 2RX, 2R square, okay, X square plus XR. So what is the value you will get? X square 3XR, and this will become minus 2XR minus 2R square is equal to 0. If you try to read from here, what is the value you will get? X is equal to 2r plus minus under root of 4r square minus 4ac, that is 4a into c, 8r square divided by 2 times of a. So what is the value you will get? 2r plus minus 8 4 12, sorry, it is 4 8 12 r square divided by 2. So what is the value you will get? You will get that is r plus root 3r, correct, or either r minus root 3r. Are you getting my point? So you tell me which will be the correct answer, which will be the correct, whether it will be the, this will be the correct one or this will be the correct, because we have two options. If you see properly, we are getting two options, correct now? So which will be the correct? So obviously r cannot be negative quantity, so this will be our correct option, correct, this is a correct option. So our answer will be r into root 3 plus 1, yeah, r plus root 3r. So our net equivalent resistance, so R equivalent will be how much? That is root 3 plus 1 into R. Now someone will ask me, sir, suppose sir, you have taken from here. If I take from here, then what will be the thing? You will get the same answer. You can try also. You take it from here, you will again get the same answer. It doesn't matter where you are taking, okay, you will get the same answer. That doesn't going to be changed, because if suppose you have an ocean and you take a one bucket of water from the ocean, it is going to affect the ocean? No. So that is what I am saying. It is not going to affect the ocean. The water will be remain same, and that is what here also. The water will be remain same. There will be no change. Clear? Any doubt? So that is the approach you have to apply to find the R equivalent for the infinite ladder. You have to simply assume at some point, and how to assume, I given you the method, and you can assume, and that is the one thing, you can assume anywhere. So you will say, some people also, oh, okay, some genius will also say, let us, sir, take it here also, here only, take it here only, and here you let us take is x, then answer, final answer will be directly x, no need to calculate. That is what I am saying. There is a proper method, you have to follow that method. Clear? That is what I have told in the earlier also, you have to follow that method. So what is the approach you have to apply? Simple approach, two-step approach. First you have to find which is the repeating unit, and then you simply see which unit is going to be repeat. Just remove one unit from that unit and then calculate the, take it as x and then calculate the value of x just by applying the simple algebra. Okay, clear? Let us take one more example so it will be more clear. Let us take one more example. Example number 2. Okay, what is example number 2? Example number 2 I am taking little easy. Let us, this is as A and this one is at B. Okay, and let this one as R, this one is also R, and let this one as R, this one is also R, and I think like this. Yeah, you can take it like this, it is going up to infinity. So again the same question is there, I am asking like REB. So my question is that how will you do? So it is simple approach. See, first you have to identify which part is repeating. If you see, you can tell from here, sir, this whole part is R is repeating, correct? So what I will do, sir, either I can take x from here, or I can say, sir, this part is repeating, correct? R, this part is repeating. So just you take x here, sir. It is possible in two manner. Whatever manner you will take, answer is going to be same only. So I am just for say, I am taking like this. Yes, sir, this part is repeating, and from here if I see the net resistance is R. So obviously from here also the net resistance will be also R. So what is the value you will get? See, you will get, sir, this is my R value, this is my R, and this value I have taken S, and from here we are getting R equivalent as X. So what is value you will get? You will get R plus X. Okay, this is my R plus X parallel with this. One minute. What will be become? R plus X into R upon, that is 2R plus X, that is equal to X. Just you multiply, you will get R square plus XR is equal to X square plus R into 2X. I will just solve it. You will get X square plus sorry, plus rx minus r square equal to 0. Now you calculate the value of x by Sidrachar method. What is Sidrachar method will say? This will become minus r plus minus, that is b square, minus 4ac, that is 4a into c divided by 2. So what is the value you will get? You will get root 5 minus 1 into r by 2, or divided by, sorry, yeah, and either root 5, either this will you will get, or minus root 5 minus 1 into r divided by 2. Obviously this is not possible because r cannot be negative, so this is my correct answer. For this, what is my r equivalent? My r equivalent will be root 5 minus 1 into r by 2, and that is a very popular answer. Okay, clear? So that is how you will find the r equivalent for an infinite ladder. Clear? Any doubt is there? Okay, so let us move to the next part. So I hope you are clear with how to find the r equivalent for an infinite ladder case. If there is an infinite ladder combination is given, what is the approach you have to take to find the calculate the r equivalent of that type of circuit. Now the next thing we are moving toward is the equivalent resistance for a cube. Okay, so basically for a cube case, this is a very famous question or very special case, cube. Okay, in cube you will see there will be three cases will be there. First is the body, first is we have h. Okay, in cube first we will see about h. Okay, so let me first draw the cube for you. So suppose this is my cube. Okay, and what is the case you have to consider at its every edge. Okay, at its every edge we have a resistance r is there, that you can treat. This is also r at every edge. Are you getting my point? Means at every edge there is a resistance r there. You can take any value, but right now just to tell you the method, okay, and keep the simplicity, you can take some different value also, r2, r3, r4, r like that. It is not necessary that it has to be r only. Okay, but if it is r, generally most of the time it will be r only. So that is why I am telling you this value, because 90% of the case for you it will be r only. Okay, so how to calculate? See, what is the step you have to do? Okay, first case we are taking about edge. Okay, so let us talk about edge. So like first we will give the number. Okay, yeah, first we will give the some numbers. Suppose this is my point 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 positions are there. So first case is what? First you try to give the numbers, and then let us we have to take edge. What is edge? See, how many edges are there? First of all, you tell me in a cube how many edges. There are 8 edges. Okay, what is edge? This, this, this corner, this corner, this corner. Okay, so how many? 1, 2, 3, 4, 5, 6, 7. This thing is edge. Okay, and similarly there, this thing is edge. So 8 edges are there, or you can see for here also. This is a type of basically a cuboid now. So this thing is one edge, this thing is another edge, this thing is another edge, this thing is another edge, behind that also another edge, like that. So there are total 8 edges in a cube or cuboid, whatever you can say. So let us consider any edge. So you can take, suppose across 1, 2. Okay, I want to calculate RAB across 1, 2. That is my one edge. So what is the approach? What is the method you have to follow? First make 2 columns. Okay, write 1 and 2. Write 1 and 2. Now rest other than this, write all the numbers 3, 4, 5, 6, 7 and 8. Obviously we have written. Now let us find the way you can go from 1 and 2. See, if from 1 I want to go to 3, means 3 is, where is 3? First you see 3 is here. How many resistance I have to cross? I have to cross 2 resistance, correct? How many resistance I have to cross? Or it will be mixed, so let us better to give some other numbers, because otherwise it will be mixed. So doing the calculation will be little like confusing. So we will, in spite of giving the numbers, we can give some other thing also. Give it as A, B, C, D. Okay, E, F, G, and H. Okay. My question is that you have to find RAB. Now it is more clear. Now what just you do, you write A and B here, and the rest you write here C, D, E, F, G, and H. Now you try to find the number of resistance you will take to go from A to C. First A to C. C point is here. How many resistance you are taking? R and R. You have to go along the edge. Okay, remember you have to go along the edge. So A to C, how many resistance you are taking? 2. Correct. Then A to D, how many resistance you are taking? 1. Then A to E, how many resistance you are taking? C. 1, 2. Okay. A to F, how many resistance you are taking from A to F? My question is from A to F. Okay. A to F, if you will go from here also or here also, you will take 3 resistance. If you can see, this is my point A. I have go to from A to F. So what is the approach? What is my approach to go? I have to take 3 resistance. There is no other approach. Okay. From A to G, A to G, A is this, G is this 2 resistance. A to H, A to H. What is A to H? A to H, how many resistance you will take? That is 1 resistance. Now just do for B also. Now this is my B, B to C, 1 resistance. B to D, how many resistance? 2 resistance. Correct. B to E, how many resistance? 1 resistance. Then B to F, how many resistance? B to F, how many resistance? 2 resistance. B to G, how many resistance? See, B to G, how many resistance? 3 resistance. There is no other approach, 3 resistance. And similarly B to H. B to H, how many resistance? 2 resistance. Now you see which one is common. See, here you are, if you try to see 2 to 1, that is one case. Okay. Similarly here also 2 to 1. Okay. Similarly 1 to 2. Similarly 1 to 2. Correct. Similarly 1 to 2. Correct. So that means these 2 points are equipotential point. So now you draw the circuit again. How will you draw? Write A and B. What is equipotential points are there? Let us see. The equipotential point, you can see C and E are the equipotential point. So let us take C and E our equipotential point. Clear? Let me draw it, write it properly. Yeah. So our equipotential points are point C and point E. Similarly, what is another equipotential point? That is D and H are the equipotential point. So we have another point, that is D and H is another equipotential point. Correct. Then what is the points are left? The point we have left is F and H. So let us write somewhere F and somewhere or we can do right here somewhere F and somewhere H. Okay, no problem. So let us now draw. First thing, if you take the point A and B, you have a 1 resistance R. Correct. Now from point A to D, we have a 1 resistance R for point A to D. So what we will do, we can do one more thing. We can bring this thing here and bring this thing here. Okay. Just for safety purposes I am doing, because safety purposes in the sense that the drawing should look proper, then only you can understand, otherwise it is difficult for you to understand. Okay. A to D we have 1 resistance R. Similarly A to H we have another resistance R. Okay. Clear? A to D, A to H. Now you get point B. Now point B, you will see how many resistance. See, point B to C we have a 1 resistance. Just erase this slightly outward. Okay. So point B to C we have a 1 resistance. Then point B to E we have another resistance. Okay. Now let us see, between D to C we have a 1 resistance. Okay, and C point is equivalent to H point now, so that doesn't matter. And between what we are saying, sorry, so A to B is done and B to C is done. Okay, A to D is done. See, A is directly connected to D, that is also done. A is connected to H, that is also done. A is connected to B, that is also done. So A point is done. Okay, now let us come to the C point. C point you can see, sorry, B point first. B to C, okay, we have done. B to E we have done. Then B to A we have done. So this point is also done. Now come to C point. C point is C to D R, done. C to D R is done. C to B, that is already done. Then C to F, what is C to F? C to F means from here to here. So what you can do one more thing, like in spite of writing like this, you can write F here and H here. So C to F you write one resistance R, correct? So C, this and this. Okay, C to F, C to B is done, this is done, so C is also done. Now similarly come to D. D point, D to C, that is done. D to A, that is done. And D to G. D to G we have to write. D to G we have to write. D to G. D to G is, where is G point? G point we haven't put. Sorry, that is point is G only, na? Okay, we have written wrong. Okay, sorry. This point is G. So between D to G, this resistance is R. Okay, so that is also done. This point is also done. D is also done. Now what is the point? Another point H. So H is connected to A, that is done. H is connected to E. H is connected to E, that is also done, because H and they both are equivalent point only. So H is connected to E. So you can connect like this. Okay, one resistance R. H is connected to E. Okay. So H is connected to A. H is connected to G. So there will be one resistance R will be there. That is here. So H is also done. Similarly, let's commit to E. E is connected to B, so E is connected to B. This point is B. That we have done obviously, because B connection is, all B connections are done. Okay, all B connections are done. That is no problem. All B connections are done. E is connected to H. That is also done, because we have drawn. H is tick mark, so H we have drawn. Now E is connected to F only. That is a connection we have left. E is connected to F. So that is a one connection we have left. That is E is connected to H. Sorry, F, R resistance. Okay, now F all connections are done. If you will see the F all connect, this connection, F to H. G, only one connection is left. So that is also done. And G all connection will be done. If you see all are marks, that means G is already done. So this is you are getting. So if you want to calculate RAB, now it is very simple. See, this will become 2R, sorry, R by 2, correct? R by 2, R by 2. This is also R by 2, this is also R by 2, R by 2. So what is you will get? R by 2, R by 2. So that is 2R. Now 2R here, so you will get here completely 2R. Now you can see here, that is, this is R by 2, correct? This is also R by 2, correct? This is also R by 2, correct? What is this value? This value is R, correct? And this is AB. Now you have to calculate this. 2R and R by 2 is how much? 2R and R by 2. 2R into R by 2 is how much you are getting in parallel. You will get 5R by 2. So R by 2 will cancel out. So you will get 2R by 5. Now that 2R by 5 is again, this 2 again is series with R by 2. So plus R. And that is whole thing is going to be parallel with R. So what you are getting? You are getting 7R by 5. That is parallel with R. So when you do this, how much you will get? So if you do this, you will get how much? You will get how much? 7R by 12. Okay, that is RAB. So RAB we are getting how much? That is 7R by 12. Across edge, what is R equivalent we are getting? That is 7R by 12. And how, what is the approach? This is the approach you have to follow. It can be anywhere. I can ask here, I have asked across the edge. I can ask in the same question, I can ask here also. That if I ask you what is R, this is about edge. Suppose I can ask you about RAC, that is across face. It will be across face. Okay, RAC across face. I can ask like that also. RAC. then in that case again you have to do the same thing. You will make what? You will make a table, you will see what are the equipotential point and you will draw. That is the same thing you will do. So let us, if you want you can do, but if you will do the calculation, what is the RAC you will get? What is the RAC? First do it and then tell me what is the RAC you will get. If you do, if you will do, you will get how much? That is 3R by 4. And similarly, if you will do across, if I ask you, similarly if I ask you across body diagonal means this point A and this point F, means opposite points, okay, RAF, okay, that is RAF, that is body diagonal. Okay, so what is R? You will get R net is equal to how much? That is almost 5R by 6. That is how much? 5R by 6. So what is the thing you have to remember in conclusion wise? If you see the conclusion, okay, what is the conclusion we have to remember? That is important, more important. Basically there is something called H, face and body. What is the answer? H, face, body. For H it is 7R by 12. For face that is 3R by 4. And for body it will be, sorry, for body it will be 5R by 6. That is a whole conclusion you have to remember. Okay. That is a whole conclusion you have to remember. And what is a method? This is the exact method. There is a lot of another methods are also there, but I am telling you the most appropriate method. If you will follow this method, it is very sure you will get, it will take a time to solve it, but it is very sure that you will get a correct answer. That is very sure. Okay, just what you have to do, you have to make this type of table and simply find the equipotential points, and then you redraw the circuit. What we are doing earlier also, that is the same concept. I'm not adding anything extra. You have to do the same thing, and if it is better you can remember the answer, because generally they will give you some, like they will give you this type of combination, and they can ask you across any 2 points. Like they can ask you, like, tell me about this point. So this point is the H point. Again the answer will be same, 7R by 12. So if it is same, then you can directly write the answer 7R by 12. Suppose they will give you the some value of R and they can directly ask you. Okay, so that type of question they can ask. I can frame lot of question. Like if you will give solve the DPP, you will get a one question. I have asked you what is the power consumed in this resistor. Okay, so here you have to calculate the current in this branch. In this branch you have to calculate the current, and when you will calculate the current, you will calculate the power consumption in this resistor. This type of question we will solve also. Okay, that is not tough, but you have to use your brain, and that is all thing is there. It's easy only. Okay, clear? Okay, just note down this formula for you, because that formula is very important. Okay, note down this formula. Completed? Okay. Now till here we have discussed a lot of things, or let us see one example on this. Okay, let us see that example that I put it into the DPP also. If you will solve the DPP, you will get that question. Basically the question is like this. That is example. What is example here? Basically this all resistance are 2 ohm. Okay, on every edge there is a resistance of 2 ohm. Okay, okay, 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm. This is the my basically I have given, and what I have asked Suppose I have applied a battery here. Question is, I have applied a 2 volt of battery. Okay. My question is that in this branch, suppose this branch is some point A and this branch is some point B. You have to find power consumed in AB. So for finding the power consumed in AB, if you have read class 10th or 12th, 10th or 12th, you know that what is the power formula. Just basic formula I want you. We will discuss power, but what is the basic formula you know? Power is equal to I square into R in resistance. Okay. So if you want to find the power in this branch, you should know the current in this branch. Okay. Then you should know how much current should be given by the battery. That is value you have to know. What is that current? So how to solve this? What is the solution? Can you think how we will do this approach? So basically will be our approach in this case? First, if we know what is the resistance across C, we have apply the battery across this edge. Okay. So what is the R equivalent we can see from this edge? If you will see. So sir, we can get our R equivalent as, if we will see, we will get our R equivalent as 7R by 12. That we know. Correct. 7 into what is the value of R, you know, that is 2 everywhere here. See what is you will get? You will get 7 by 6 ohm. That is my R net. If it is R net is this much, what is my current? My current will be, that is V by R. What is the value of V? That is 2 and this is 7 by 6. So what is the value you are getting? 12 by 7. That is my current. Now let us come here. See, this current is I here. Okay. Coming. Now it has a 3 path and all the 3 paths has the same resistance, correct? Same resistance, correct? So I can say the I by 3 will go here, I by 3 current will go here, I by 3 current will go here and I by 3 current will again go here, correct? Now this I by 3 is going here, it's coming again, there is a 2 paths are there. What is the current will go? It will again distribute into I by 6 and I by 6, correct? Like that. I by 3 again here there will be 2 currents will be distributed. I by 6, I by 3 will divide into 2 parts, that is I by 6. I by 6 from coming from here, I by 6 will coming from here, it will become I by 3 from here. Now I by 6 is coming from here. Similarly I by 6 is coming from here. Now here I by 3 is also coming, so again here I by 6 and I by 6. Because equally it is dividing. Now I by 6 coming from here, I by 6 coming from here, it will get I by 3. Now again I by 6 coming from here, I by 6 coming from here. So what is the value you will get? Finally I by 3. So like that it will be all 3 will be divided. But what is important for you? You should know the current in this branch. What is the current in this branch is there? That is I by 6. The current in this branch is I by 6. Correct or not? If the current in this branch we know that is I by 6. So what will be my power consumed? So power consumed will be in AC. Okay, AB will be I square into R. What is the current? That is I by 6. So I square by 36. What is R? R value is 2 ohm. So when you put the value, you will get I square by 18. Now what is I square? This is the value of current. So 12 into 12 divided by 49 into 18. That much the value. So what is the value you will get? 12 into 12. That is how much? Or you can say 4 3 12, or you can say 3 4 12, 3 6 18. Okay, so this will become 4 12 into 6 into 49. So 2 and then 3 then 4. So 8 upon 49 watt. That is a power consumed in this branch. Clear? What you have to simply do? You have to simply divide the current. Okay. Just you have to simply do the division of current. So these types of questions are there in the DPP. For getting the DPP, you have to simply join the WhatsApp group, which is available in the description box below in this video link, or any video link, or you can go to the channel also. In that channel there is a separately we have a WhatsApp group link. You can directly join that group and you can get all the DPP's notes and everything. Okay, just you have to join that group. So these type of questions you will get. Clear? This is going to be a good question for the JEE mains point of view. Okay, they can ask this type of questions. In NEET also there is a probability that they can ask. Okay, in NEET also there is a probability. Clear? Any doubt till here? Any doubt? I hope everything is clear till here. Okay, so till here we have discussed about everything about the R equivalent. I hope you know, now you know all the methods. If I give you any circuit, you can calculate the R equivalent, and we have discussed all the, like we have seen the examples also, that how to solve that R equivalent basically question. So till now we this circuit theory part is completed. Now you know how to solve any circuit, how to calculate the R equivalent of any circuit, and if you know the R equivalent, you can calculate other parameters also, if that we will discuss soon. So this circuit theory is now completed. So we have completed our circuit theory. Till here our circuit theory is completed. Circuit theory is completed. Okay, so circuit theory part in our this chapter is completed. Okay, so till here we have completed our circuit theory part. Now in the next section we are going to start the electric power, and we will see the power concepts of power. Okay, till then take care, and if you like this session, please like it, share it, subscribe it. Have a nice day. Thank you.